the human population on Earth is increasing day by day, the scientists are continuously finding and exploring many things in space that could serve as a planetary living basis for humans. You may be astonished to know that there are many other planets in our solar system beyond the 8 basic planets. An example of such a planet orbiting the Sun is called a dwarf planet. Well, keep watching Gateway to Knowledge to know that how scientists of United States have found that the dwarf planet Ceres is actually an oceanic world. But what are these dwarf planets and how they would look like? Dwarf planets are round in shape and orbit the Sun just like the 8 major planets. But unlike planets, dwarf planets are not able to clear their orbital path, so there are no similar objects at roughly the same distance from the Sun. A dwarf planet is much smaller than a planet. It is even smaller than the Earth's moon. The first 5 recognized dwarf planets are Ceres, Pluto, Eris, Makemake and Haumea, and all of them are uniquely mysterious. The dwarf planet Ceres, which lies in the main asteroid belt between Mars and Jupiter, has a diameter of about 940 kilometers. According to a new study, this dwarf planet, which was long considered as having a rocky surface, is actually an ocean world with reservoirs of seawater beneath its surface. Scientists from the United States and Europe analyzed images obtained from NASA's Dawn spacecraft that were captured around 35 kilometers from the asteroid. The images revealed crisp details of mysterious bright regions for which Ceres had been known for. These bright regions on Ceres were actually deposits that are made up of sodium carbonate, and this compound is made up of sodium, carbon and oxygen. All these constituents came from the liquid that percolated up to the surface and evaporated, leaving behind a highly reflective salt crust. But what they had not yet determined was where that liquid came from. By analyzing data collected near the end of the mission, Dawn scientists have concluded that the liquid came from a deep reservoir of brine or salt-enriched water. Then they studied Ceres' gravity to learn more about the dwarf planet's internal structure, and they determined that the brine reservoir is about 25 miles deep and 100 of miles wide. This study confirms that the Ceres is a water-rich world like other icy bodies. Not only that, but scientists came to know that these bright regions are actually young. And are less than 2 million years old. And the geologic activity driving these deposits of sodium carbonate are still going on. On the Ceres surface, salts-bearing water quickly dehydrate within hundreds of years. But the NASA's Dawn spacecraft measurement shows that they still have water. So the fluids must have reached the surface very recently. This is an evidence for both the presence of liquid below the region of Occator crater and the ongoing transfer of material from the deep interior to the surface. But how does this liquid reach the Ceres surface? The scientists have found 2 main paths that allow the liquid to reach the surface. The large deposit of the bulk salts was supplied from a slushy area beneath the surface that was melted by the heat of the impact that formed the crater about 20 million years ago. The heat of this impact subsided after a few million years. However, the impact also created large fractures that could reach the deep, long-lived reservoir, allowing brine to continue percolating to the surface. This has given very huge information to us because we previously assumed that the bright regions on the surface of Ceres was ocean. But after this finding, we are very much determined that the oceanic surface of this dwarf planet came from the salty water underneath. To know more about space, technology and advancement in interdisciplinary sciences, do subscribe to my channel and don't forget to press the bell icon to get notified about my new videos.